Good morning, BSRT2 students. Before we move on with our final lecture, I think we deserve a round of applause. Yay! So, natapos din tayo sa ating online classes for this subject, RT212, Radiation Production and Characteristics. And I hope may natutunan naman kayo kahit papaano, ano? Ay, salamat. So, I hope next time meron na tayong face-to-face. So, now, this morning we are going to discuss the radiation interaction with matter. So, in our previous module, so we have learned that radiation production is in two processes. We have characteristic radiation and Bremsstrahlung X-rays. So, now the question is, how will this produced X-ray interact with matter? We are talking about the object that is in the diagnostic imaging room, either the patient, the rad tech, or something else. But before that, let us have this short introduction, considering our electromagnetic spectrum, the parameters that we already discussed, the wavelength, the frequency, and of course the energy. So X-rays have very short wavelengths. So theoretically, this range from approximately 10 raised to the negative 8 to 10 raised to the negative 9 meter. So the higher the energy of an X-ray, that is according to the Planck's quantum theory, the shorter is its wavelength. Okay, so therefore, what will happen to the frequency? Shorter wavelength, meaning higher in frequency. Pag higher in frequency, what will happen to the energy? So, mas taas gihapon ang energy. So, consequently, the low energy X-rays tend to interact with the whole atoms, which have diameters of approximately 10 raised to the negative 9 to 10 raised to the negative 10 meter. Moderate energy X-rays generally interact with electrons, and high energy X-rays generally interact with the nuclei. So, ito lang yung mga kailangan nating tandaan. So, when we say low energy photons, their interaction is with, again, with the whole atom. Pag moderate energy X-rays, the interaction is with the electrons. And with high energy X-rays, their interaction is with the nucleus. Okay? Sige. So, now, let's move on with our discussion. So, X-rays interact at these various structural levels. Pwedeng through coherent, pwedeng Compton Scattering, pwedeng Photoelectric Effect, pwedeng pair production, and Photodisintegration. But, sasabihin ko na lang in advance, for your assignment, please submit a written report as to yung magiging summary natin, yung magiging format ng magiging summary natin with our discussion. So, you make a written report on Cherenkov radiation. Okay? Cherenkov radiation. Hindi siya na-mention dito sa 5. So, pang-6 siya technically. So, bibigyan niyo ako ng report as to magiging format ng ating discussion. Okay. So, first, we have coherent scattering. Coherent, in other words, this is called the classical scattering. Yan, coherent or classical scattering, similar lang na, synonymous. So, X-rays with energies below approximately 10 kilo-electron volt interact with matter by coherent scattering. So, this is called, or sometimes called, classical scattering. So, classical scattering or coherent scattering has two types, liwat. So, we have Thompson and we have relay scattering. Okay, so pag Thompson scattering class, the interaction is with an electron or orbital electrons. Pag relay, it is with the whole atom. So, uturon ko lang ha. When we say Thompson scattering, this is a classical or coherent scattering with low energy photons interact with an orbital electron. Whereas a relay scattering is a type of coherent or classical scattering that involves a low photon interacting with the whole atom. Okay, I hope you won't be confused. Okay, so in coherent scattering, the incident X-ray interacts with the target atom, causing it to become excited. So, the target atom immediately releases this excess energy as scattered X-ray with wavelength equal to that of the incident X-ray and therefore of equal energy. However, the direction of the scattered X-ray is different from that of the incident X-ray. Kung napansin mo ito ang flow and description, mapansin mo there is no ionization. So let's give a simple analogy. So ikaw may crash. So nag-chat ka, mo crash. Tapos ginsin ka la niya. So that is a typical analogy of a coherent scattering. So there is no actual interaction between you and your crush. Nag-message ka la ginsin. So coherent laan na tabo. Ay, sana all. Balital. Next, the result of coherent scattering is a change in direction of the X-ray without a change in its energy. There is no energy transfer, kaya waray man interaction between them, kumbaga umagila si photon sa atom. And therefore, no ionization. So, most coherently scattered X-rays are scattered forward direction. So, coherent scattering is of little importance to diagnostic radiography. Kasi nga, kung mapansin niyo, low an aton, photon. Remember that based on our principles of imaging, our X-ray photons or diagnostic radiography range is from 30 to 150 kilo-electron volt or kilovolt peak. That's why we can say that coherent scattering is of little importance to diagnostic radiography. So, coherent scattering primarily involves low energy X-rays, di ba? 10 kilo-electron volts, which contribute little to medical imaging. Some coherent scattering, however, occurs throughout the diagnostic range. So, at 70 kVp, a few percent of the X-rays undergo coherent scattering, which contributes slightly to an image noise. Which we say image noise, it's only a fluctuation or this generally graying of an image that reduces the image contrast. What else? So X-rays through So as a summary, ito yung sinasabi ko kaninang summary na format natin. Format natin na gagawin nyo for Cherenkov radiation. Summary. Una, what is the energy of photon? So the energy of photon is considered low energy photon, di ba? 10 kilo-electron volts or below. So the site of interaction. Site of interaction, posible dalawa, di ba? When we speak of Compton scattering, it is with the pag Compton scattering, it is with the orbital electron. That is with relay scattering, that is with the whole atom. What else? The end product. End product of coherent scattering is only a scattered radiation. Kasi nga there is no interaction, there is no ionization involved, only nag-pass through lang ang X-ray sa atom. So yon yung coherent scattering. Next, we have Compton scattering. So, I would like to emphasize, class, that only two types of interaction can happen in diagnostic radiography. One of which is Compton scattering. The other one is photoelectric effect. Sila lang dalawa ang malaki ang chance na mangyari sa X-ray. Considering natin yung energy and of photon. So X-rays throughout the diagnostic range can undergo an interaction with outer shell electron that not only scatters the X-ray but reduces its energy and ionizes the atom as well. This interaction is called Compton scattering. Kung kanina sa coherent scattering, after kay J.J. Thomson or kay Lord Rayleigh, ito naman sa Compton scattering, this is named after Arthur H. Compton, an American physicist. Next time, if meron na kayong madiscover, so posible na kayong magkaroon ng name sa and whatever diagnostic value meron dyan. Okay, so in Compton scattering, the incident X-ray interacts with outer shell electron and thereby and ejects it from the atom, thereby ionizing the atom, di ba? Pag sinabi nating ionization, so this is the removal of an orbital electron from the atom. Yan. So the ejected electron is called Compton electron. In some other books, tawag siya recoil electron. Pwede din siyang tawaging secondary electron. Yon. Kung ano yung pinaka-comfortable na tawag mo sa kanya, Compton electron, recoil electron, or secondary electron, isa lang yon. Siya lang yung electron na product ng Compton interaction. So the X-ray continues in a different direction with less energy. So kung kanina, nasin ka lang ng crush mo, so ito naman, ito yung tipo ng pag-ibig na hindi niya ibinigay ang lahat. Nagmahal siya, pero may hinahanap pa siyang iba. So, naghatag siya ng energy nga di sa electron, pero may yaon pa siya energy para, kasi may scattered radiation pa siya, di ba? So, the energy of a Compton scattered X-ray is equal to the difference between the energy of the incident X-ray and the energy of the ejected electron. So, the energy of the ejected electron is equal to its binding energy plus the kinetic energy which it leaves the atom. Sige, di rin na natin i-detail ini nga portion or ini nga slide. So during Compton scattering, most of the energy is divided between the scattered X-ray and the Compton electron. Usually, the scattered X-ray retains most of its energy. Both the scattered X-ray and the Compton electron may have sufficient energy to undergo additional ionizing interactions before they lose the energy. O sabi pa nga, both the scattered X-ray and Compton electron, naghahanap pa ng iba, may undergo additional ionizing interactions before they lose their energy. So yan, i-discuss natin ano ang mga posible matabo with the use of or with Compton scattering sa diagnostic radiography. So Compton scattering in tissue can occur with all X-rays and therefore is of considerable importance in diagnostic imaging. However, its importance involve negative sense. No? May maraot ngayon iya impact sa radiography. Number 1, scattered X-rays provide no useful information on the radiograph. Diba? It can only fog the film. So one of its major contributions sa diagnostic radiography is the scattered X-rays na nagfa-fog or nag-increase ang density or optical density ng X-ray film. So they provide a uniform optical density on the radiograph, which in turn reduce the image contrast. Yon. So that is why pag naghahataas ang KVP, di ba, technically, nag-i-increase lahat ang scattered radiation. And we said in the former module that the number one source of scattering radiation is the patient. Di ba? Kasi scattered radiation are byproduct of attenuation. Therefore, we can say Compton interaction is a byproduct of attenuation. So the scattered X-ray naman, hatawo from Compton scattering can create serious radiation hazard in radiography and particularly in fluoroscopy. A large amount of radiation can be scattered from patient during fluoroscopy. Such radiation is the source of most occupational radiation exposure that radiographers receive. Tigam nito ha, sa radiation protection, that is why kailangan natin magsulotin personal monitoring device and or lead gowns kasi may Compton radiation. May scattered radiation brought about by Compton effect. So the source is of course the patient, not the X-ray mismo. So during radiography, the hazard is less severe because no one but the patient is usually in the examining room. Okay, so kita kasi we are shielded sa ating operating console, di ba? So may concrete barrier. Yan. So not unless an imo direction and imo useful beam is towards you. So iba itong istorya. So nevertheless, scattered radiation levels are sufficient to necessitate protective shielding of the examining room. So that is all about Compton scattering. So isama rin natin. Una, the energy of photon, of course, that is in the diagnostic imaging or diagnostic X-ray range, that is from 30 to 150 kilo electron volt. So potentially we can consider it, iba nga book considered siya as low to moderate, and iba naman moderate to high. Okay, so the site of interaction is of course outer shell electron. So end products, una we can say Compton electron or recoil electron or secondary electron. Next, the scattered radiation, scattered X-ray. So mga end products yan. So may interaction, of course, there is ionization. Kaya lang, diri tanan nga energy han incident photon iya ginhatag. It does not give all of its energy. Rather, it gives some of its energy. Bago nga naton, isa siyang pagmamahal na hindi ibinigay ang lahat-lahat. May hinahanap pa siyang iba. So, gives some of its energy. So, therefore, nag-produce din siya. May ionization din siya. May production din ng ion pair. The Compton electron is the negative ion, and the atom where the electron was removed will now become a positive ion. Okay? So, sige. I hope nakuha niyo. Now, let's move on to the next interaction, which is the photoelectric effect. So, X-rays in the diagnostic range, again, from 30 to 150 kilo electron volt or kVp, can also undergo ionizing interactions with inner shell electrons. Kaya nga ni-uturohan ko la class ha, I would like to emphasize that there are only two radiation interaction with matter that can occur in diagnostic imaging range. Only Compton effect and photoelectric effect. So the X-ray is not scattered but is totally absorbed. So, may keyword kita didi, absorbed. In any exams, like for example, chapter exams, final examinations, pag makita ka mo nga naghahanap hin radiation interaction nga nag-absorb, so usala it makadat imuhuna-huna, that is photoelectric effect. Because this is called radiation absorption interaction. Okay? So, kung kanina si Coherent, na-discover siya ni J.J. Thompson, and Compton effect, na-discover siya ni Arthur Compton, si photoelectric effect naman, na-discover siya ni Albert Einstein. The photoelectric effect or this process has earned Albert Einstein the 1921 Nobel Prize in Physics. So, in photoelectric effect, the electron is removed from the atom. Therefore, may ionization gihapon. Kasi, di ba, ionization, this is the removal of an orbital electron from the atom. So, tawag na naton kanya, derila kay electron. The photoelectron na siya, which escapes with kinetic energy equal to the difference between the energy of the incident X-ray and the binding energy of the electron. So, masugad ka, sir, may kapas pa ba siya? Yes, pwede siya. May kapas pa siya mag-ionize to other matter. What else? Characteristic X-rays are produced after a photoelectric interaction. Kung kanina sa Compton effect, yaon siya scattered X-ray or scattered radiation. Sa photoelectric naman, yaon siya characteristic X-rays. So, diri kita exempted nga waray X-ray, However, diri paros ka severe effect sa photoelectric effect sa aton as radiographer. Actually, sa image, mas nagproproduce it photoelectric effect ng contrast, better contrast than with Compton effect. So, ejection of a K-shell photoelectron by the incident X-rays result in a vacancy in the K-shell. So, I hope you still remember kung paano ang process ng characteristic radiation, di ba? So, there's an inner shell void, tapos the outer shell electron will fill the pagkukulang inside the electron shell kasi abnormal ang atom pag may inner shell void. So, pupunan yon ng mga outer shell electrons. Sana all napupunan ang mga pagkukulang. Char. So, this unnatural state is immediately corrected with an outer shell electron, usually from L shell drops into the vacancy. Yun ang explanation ng characteristic radiation. So, this electron transition is accompanied, okay, so wag na nating pahabain pa kasi alam naman natin yung production ng X-ray with characteristic X-ray. Ito na lang. These characteristic X-rays consist the secondary radiation and behave in the same manner as scatter radiation. They contribute nothing of diagnostic value and fortunately have sufficient low energy that they don't penetrate the image receptor. Actually, in some other books, the description is contrast. See, photoelectric effect. A photoelectric interaction cannot occur unless the incident X-ray has sufficient energy. Kaya nga, nasa diagnostic value range tayo. Actually, some authors describe photoelectric effect as moderate to high. Kaya sufficient ang kanyang energy. So, it will undergo a photoelectric effect, decreases with the third power of photon energy. So, let's give a summary on photoelectric effect. So, una, the energy of photon, of course, diagnostic energy range, that is from 30 to 150 kiloelectron volt. The site of interaction, inner shell, as compared with Compton effect na nasa outer shell, si photoelectric inner shell. Diba? So, end products. Una, photoelectron. Diba? Next, characteristic radiation. Diba? Kasi nga, ang photoelectron coming from the inner shell, so pupunan ng ang pagkukulang ng mga outer shell electrons, so nagkakaroon siya ng characteristic radiation. And of course, because there is an ionization, technically meron tayong ion pair. The photoelectron, which is a negative ion, and the atom where the electron was removed will become a positive ion. Okay. So, kung kanina si Compton effect, tipo ng pag-ibig na hindi ibinigay ang lahat-lahat. So we can say si photoelectric effect, isa siyang klase ng pag-ibig na ibinigay na ang lahat-lahat ng kanyang pagkatao, kanyang load sapatos, pero ang ending naghanap pa rin ng iba. Diyos. Balitaw. So what I'm trying to say is to induce ionization, so it gives all of its energy to the inner shell electron. So, it will be removed from the atom. Okay? Huwag na kayong maging nega-nega ha. Okay, next. We have the pair production. So, if an incident X-ray has sufficient energy, it may escape interaction with electrons and come close to the nucleus of an atom to be influenced by the strong nuclear field. So, class, tigamnan natin, again, an atom introduction with this module. Pag low energy photon, iya interaction is with the whole atom. Pag moderate, an iya interaction is with an electron. Pag high energy, the interaction is with the whole atom. So, the interaction between the X-ray and the nuclear field causes the X-ray to disappear. Yan, na-absorb lang, no? And in its place appear two electrons. One positive, the other one is negative. So, this process is called pair production kasi nag-produce siya ng pair. Isa nga positive, a positron, and isa nga negative, which is a negatively charged electron. So, the energy equivalence of the mass of an electron is to be 0.51 mega-electron volt. So, because two electrons are formed in pair production, the incident X-ray must have at least 1.02 mega-electron volt. Again, ito, negative electron, ang magiging energy niya is 0.51 mega-electron volt. Ito, kasi nagmo-move. So, the other one, the positron, ang energy din niya is 0.51 mega-electron volt. So, i-add mo, 0.51 plus 0.51, so that will give you 1.02 mega-electron volt. So, therefore, the energy of photon must have an at least 1.02 mega-electron volt. Pag below 1.02 mega-electron volt, dire siya pwede mag-undergo ng pair production. So, an X-ray photon with less than 1.02 mega-electron volt cannot undergo pair production. How about, sir, kung nataas? So, any of the X-ray energy in excess of 1.02 is distributed. So, pag halimbawa 1.04, so magiging 0.52 na ang magiging energy ng negative electron and positive electron. It will be distributed equally between the two electrons as kinetic energy. Yun naman pala. Kaya pair production. Kambal na kambal. Exact an energy. However, magkaiba lang era sign. Other one is positive, the other one is negative. Kaya pair production. Next, the electron that results from pair production loses energy through excitation and ionization, eventually fills a vacancy in atomic orbital shell. So ito yung mangyayari sa mga electrons, isang positive and negative. However, the positron unites with a free electron. Yan. So may sense pala yung law of attraction, di ba? Positive, ma-attract siya sa negative. So, a positron unites with a free electron. And the mass of both particles is converted to an energy. Again, this process is called annihilation. So, a positron with an energy of 0.51 mega electron volts unites with a negatively charged electron. So, the process is called annihilation. So, hindi nagtatapos ang pair production with the creation of negatively charged electron at positively charged electron. Bagkos may continuation pa. This is with the annihilation radiation. So, because their production involves only X-rays with energies greater than 1.02 mega electron volt, it is unimportant in X-ray imaging. So, sa diagnostic energy or sa diagnostic X-ray, our energy is only from 30 to 150 kilo, hindi siya mega, kilo electron volts. So, therefore, it is important or unimportant in diagnostic. So, it is important for positron emission tomography in nuclear medicine. Tinatawag yan PET scan. Kung nakabati na kamo, PET scan. So, positron emission tomography. That is one of the major contributions of pair production. Okay? So, let's have a summary on pair production. So, the energy of photon should be at least 1.02 mega electron volt. The site of interaction, of course, nasa nucleus na. End products. Okay, so dalawa ang magiging end products niya. One, negatively charged electron with an energy of at least 0.51 mega electron volts. And the other, a positively charged electron with an energy of 0.51 mega electron volts. Actually, may continuation pa na process, annihilation. This is when a positively charged electron with a charge of 0.51 mega electron volts unites with a free electron. That is an annihilation process. Okay, sige. Last, but definitely this is not the least interaction kasi ang taas ng kanyang energy. So, X-rays with energy above approximately 10 mega electron volts can escape interaction with electrons and the nuclear field and be absorbed directly by the nucleus. So, pag higher than 10 mega electron volts, so absorb na siya sa nucleus. So when this happens, the nucleus is raised to an energy state and instantly emits a nucleon or other nuclear fragment. Pag ma-absorb ang high energy photon, so may kabalyo siya, usa nga nuclear fragment. We can say a proton, an electron, or meson, lepton, basta tikang siya sa nucleus. This process is called photodisintegration. So, as a summary, photodisintegration, the energy of photon is, okay, 10 mega electron volts or higher or above 10 mega electron volts. The site of interaction is with the nucleus of an atom. Okay, so what happens next? Okay, so the interaction, so the photon is absorbed in the nucleus. So the end product is a nuclear fragment. Nuclear fragment can say proton, neutron, electron, basta tikang siya sa nucleus of an atom. So that ends our lecture for today and definitely ends our lecture for the whole semester. Yay! So if you have concerns, if you have questions, violent reactions, wag naman sana, so you can reach me in different platforms. So, this has been your teacher, your professor, your host, well, your vlogger, saying, God bless everyone, and I hope kita-kita tayo next semester. Sana hindi na online classes. Sana meron na tayong actual face-to-face para makapag-laboratory naman tayo, di ba? So, Hanggang dito lang muna tayo. Bye-bye!